Welcome to Wild West Garage, and if you're new here, my name's Morgan. I'm expecting some new arrivals considering the topic. It's not what I usually do. I'm not a motor guy, but this car is a 1958 Edsel, and it's got an electric shift motor in it. A little 12-volt motor with a gear, like a worm gear drive, that shifts the transmission. So the other day I went to back this thing out of the shop and it wouldn't come out of park because it was on a bit of a, it was on the ramps to the pit here a little bit, and there was some pressure on the drivetrain and it wouldn't come out of park. So I jacked the car up, got the pressure off it, managed to get it into drive, but then it wouldn't come out of drive. So that was the last effort for that motor. It got too hot, and you know, I think this has happened before with this car, where it the car was stuck on a hill or something, and the owner couldn't get it out of park. So it just took its toll on that little motor. So I've got it in the shop here, in the back shop. So let's go take a look at it. So I started working on this thing, and I had the camera rolling on it, and I broke one of the terminals right off the contact here, the, what do you call this, commutator ring, and I was so disappointed or so upset that I just deleted all the footage. But anyways, I'm gonna, so then off camera I went at it a little bit and I'll explain what I did. So this, as you can see, I've gone at this thing. So these, see, there's one that came apart nice. So what it is, it's a little tab that's on here, right? Extension onto this. And then it doubles over on itself and the wires get crimped in there. I thought maybe these were soldered, but it appears that they are somehow, they're welded. So during the manufacturing process, they put the windings, hook it over this little tab here, and then they bend it down and electrically like arc weld it together somehow. So this is the one that broke off. So I just I had to back away from it. I went and had some lunch, and then while I was kind of cooling off, I thought, well, I'm going to come out here and try and solder onto this and see if I can get a solder lug on there. And that's what I did there. You can see that there's some solder on there, and I've kind of filed it down. So then I went at it trying to get the rest of these off, and I didn't want to break any more of them off, so I got this little Dremel tool cutting disc thing, zip disc. I don't have a Dremel tool. So I just put it in my drill, and I managed to cut those open, the rest of them open. And it's a bit of a mess, but like I like to say, an old friend of mine used to say, well, it's already wrecked, you know. So anyways, it's more wrecked now, but I think I'm going to be able to salvage it. So then the next thing I did, I had to determine how many wraps they've got on each, you know, each winding here. So I just cut through the wires. You can see, you know, see, that's what it looked like on the other side, just straight over the top here. So I just cut through all those wires, and I've counted them. There's 15 windings around 3 poles here, see, right? So this one connected here. So that's the final wrap, of course, on the outside of everything. So I realized that I ordered a spool of wire, and I realized that there's two. This has 8 poles, so you divide it into 4, and there's 4 poles that are on like opposite each other, right? So there's two groups of 4 that you gotta. So I ordered 1 coil of wire, but I think I needed to have 2 coils of wire so I can wrap these simultaneously, like wrap one side, go to the other side to wrap it. I'm not going to be able to do that properly with 1 coil of wire, so I might have to just coil some of that wire onto a different spool and go at it like that. Anyway, enough rambling. I'm going to start ripping this thing apart. So I got this all cleaned off. Still bits of wire attached to the poles here, but I'm not going to try and get those wires out. I'm just going to wrap over, well, I'm going to clean them off flush, but I'm not going to try and get them out of there. I don't want to break those. So it cleaned up good. There's no damage to the insulation on the inside of this. So now I just got to go ahead and start rewinding it. Okay, one of the things you want to do before you, or once you've got this all this wire stripped out of it, here's a piece of it, right? You saw that, well, and maybe you didn't see that coming out of there, but is these contacts, see how I've got them all numbered? That's kind of irrelevant at this point, but they're individual, there's 8 of them, and I've got them numbered from 1 to 4 and then 1 to 4, right? There's 2 sides to this thing. So you want to make sure that none of these terminals or contacts on the commutator, I think that's what it's called, have continuity. That's an open circuit right now. So if I touch these together, it's going to go to 0. That means there's 0 resistance, and that's open. So you just go along and you touch these on each individual. So you want to make sure they're not shorted together and they're not shorted to ground. So I did have, let's see if I can find it, 2 of these. These 2 terminals here had continuity between them. So the only way that could happen is if something's in this gap here. See there's gaps between the contacts. So what I did, I figured there must be some junk in there, so I just took this razor knife blade and I just kept cutting through here until I removed the piece of junk that was causing the short, and it's all good. It's no longer shorted out. So there's no point in rewinding this thing if these segments are shorted out. So let's get into the winding process. So you can see how I've got this numbered. So this is number 1 contact, I'm going to call it right here. And this is the number 1 pole, magnetic pole on the, I think this is called an armature. So what I'm going to do is I'm going to wrap wire from this terminal here into this groove. I'm going to come over to 3, the other side of 3, and wrap it back to that number 1 terminal. I'm going to do that 15 times, and then I'm going to go to the other side, the other number 1, and do the same thing. Wrap this up 15 times, and then I'll cog over to 2. So I'll take this tail that so I'll go down here. I think I'm going to go this way actually. I'm going to go this way. I'm going to start wrapping it in this direction. Oh, that doesn't make sense. No, I will go that way. And then when on the last wrap on 15, when I get to 15, I'm going to come over here and jump over to the number 2 terminal. Start wrapping on there, and then it'll just keep going around until I get to 4, and then I'll be done. But you have to alternate from side to side when you do this. You can't just go 1, 2, 3, 4 on one side. You got to alternate because these windings cross over each other eventually. It has to be balanced out. So it's really too bad I don't listen to my own instructions. So you heard me talking my way through this, right? And at first I screwed up because I said I'm going to start at 1 and wrap it and then hook it back to 1. But then as I went through it, I realized no, I have to jump over to the next, the next winding, right? Because it has to keep going around. So if you keep watching the video, you're gonna understand what happened and where I made a mistake. I made a big mistake winding this motor when I finally got down to doing it. But I did figure it out. I did fix it. I didn't fix the winding, but I fixed something else, or I did something else that made the motor work in the end. So if you're interested in troubleshooting your own stupid mistakes, learning from something, I learned a whole bunch on this job. One thing I learned is take pictures, take notes, and do what you say you're going to do, and everything will be all right. So I've got the first coil on there, but I'm having a bit of a struggle with getting the right gauge wire. So this is the second batch of wire that I bought for this thing so far, and I thought it was, I don't know what happened the first time, but I ordered 18 AWG, and I think that was just a mistake. I don't think I thought it was 18. I just accidentally ordered it. So then I came back out here and did some measuring, and then I thought, oh, okay, it's 20 AWG, but it turns out it's 21. So this is still a little bit too thick, so I'm worried I'm not going to be able to get enough at 15 wraps, that I'm not going to get it all in here. So we'll see what happens. I'll know after the third wrap. So I started at number 4. I'm working my way back to 1. So now I got to go to this side, and this is where my wire terminal broke off. So I'm going to have to solder this one on. And I've got 2 rolls of wire here, see? On this little stand that I just threw together, a piece of ready rod and a block of wood. So you just got to keep alternating between these 2 rolls of wire, because you don't cut the wire until you've done the 4, like the whole side of the armature, complete one side. So because I've already got this soldered up here, I've got the solder, tinned onto there. Hopefully this goes easy. Here's my solder. It looks like it's connected, and I don't know what's going to happen with this solder connection. I think there's a reason why they don't use solder to connect these, because if it gets a little bit hot, it might disconnect. But that's all I got right now, so I got to go with it. That's That's on there good. So I'll just go ahead and count 15 wraps on this. That's one. Okay, I'm on 9. I'm going to complete 9. And then I'm going to leave some stuffing here. So that's 9. 9 complete wraps. The tool, I just got to push this wire in here. Make sure I'm going to have enough room. We're on 9, right? 9. 9 and holding. If you can see what I'm doing here. Wraps. Going for 10. That's 10 completed. Starting 11. 11 wraps completed. You can hear me over my furnace. 11, so we're starting on 12. It's 12 wraps completed. This is 13. So let me come over here and we back step to terminal number 3. I'll just hook that on there temporarily. So now, see on this side, oh it's not, yeah, on this side. So it's going to start here and it's going to go into this slot here where there's already wire. So I'm going to figure out pretty quick here if this thing is going to take 13 wraps. So as I got into wrapping the windings, the first 2 windings, I kind of got the feeling that I wasn't going to get 15. So it ends up being 30 wires in each one of those slots. I didn't think 30 wires were going to fit in there, so I knocked it back down to 13. So that's why I'm talking about 13 now. I don't know if it is or not. It just looks pretty crowded in there. Looks really crowded in there. It cannot stick up past the shiny surface of the armature poles. I don't know if I'm going to get this wire in here like this. At this rate, I might have to go to 12. 5. Number 5. Let's do some shoving here. I don't think this is going to happen. Not even with... maybe. So it's 5 wraps. So that's 10. Yeah, it might go in there. 10. 11. 11. 12. 12. It's 12. 13. Oh boy. 13 just makes it. You know, I probably could have fit. Probably could have done 14. There's room for 2 more wires there, but I'm not going to unwrap this now. Okay, so what I'm going to do, I'm going to commit to this. I'm going to scratch this wire up here a little bit and see if I can solder over this. Close this up. I'm going to solder these now.
Said I wasn't going to solder them, but I'm here now, so.
So I've reached my I've reached my 7,500 subs. I got 7,600. So I got to give away a pipe. That will be, I'll be showing you the questions for that contest on this video. Man, I don't like the way some of these wires are laying here. Yeah, so the time has come. Pipe must be given away. So that'll be nice for somebody, I hope. That's the whole idea. Somebody gets something for free. Well, they got to work a little bit. We all got to work a little bit. I've given several of these pipes away already to people that I thought, you know, that helped me out. People that kind of part of my journey. Of course, Billy's got several of my pipes. He's a big part of my journey here on YouTube. So this motor is going to draw a little harder now because I've upsized the wire and I've reduced the number of wraps, so it's less resistance. It's going to draw more amps. So it could be the runtime on this motor isn't real high, so like, you know, to shift it from, solder up on here now. You know, it only runs for, you push the button, it goes, shifts the gears. It only runs for a second maybe, not even that, ideally. So, you know, the chance of it getting hot is pretty slim, unless it gets stuck in park like it did on me. That's kind of the downfall of these things, right? That's what kills them. It gets stalled, the motor stalls, and then you know, an electric motor draws the most current while it's stationary, like not spinning. That's when it draws the most current. The slower a motor goes, the more current it draws. And 13. Lucky number 13. Right here. Almost home. Almost got this beat. So there we go. Got it all rewound, and I used super glue, some Gorilla brand super glue, to glue in between the segments to hold everything together, because I think you know, when this motor spins up, it's going to create centrifugal force, and the windings could just fly out of there, and of course I don't want that to happen. And the reason it's got this frosty look is because I looked up on the internet, and one guy said you could use isopropanol alcohol 70% with water 30% as a curing agent for super glue. I didn't have any of the alcohol, so I just misted a bit of water on it, and so this is what happened. I think it did cure it a bit, or kick it off a little bit quicker. But anyways, it is what it is now. I don't know if this is going to work. It's just a great big experiment for me. And then of course I gotta file back some of the solder, and I also learned that solder is not, or soft solder is not generally accepted for use in electric motors. It should be silver soldered. I don't have any silver solder, and this is, you know, just a great big experiment anyways. I think it's going to work. I don't know if it's going to work. I sure hope it's going to work. So I got to get this commutator cleaned up, and I'll put this back in the casing and give it a try. Okay, so I've got this all assembled, and just got it taped together because there's these two holes here. See that? Screws go through here, and this gets bolted onto the you know, the housing, the worm gear housing. And so this cap here is just a this is a plug that goes into a, you know, like a camshaft on an overhead cam engine. This is the outside cap, right, that gets sandwiched down into the saddle. So I just drilled a hole in it, 1/4 inch hole, just because I need to center this, otherwise the motor's not going to run, because the armature is just going to get pulled onto the I don't know, field windings. Okay, so I'm just going to show you how this actually works. And it doesn't run real good because this isn't centered very nicely. There you go, it works. And it makes pretty decent torque too, because if I put it up against this block here, it doesn't stop it. So it's good. It's a good strong motor. Doesn't turn high RPM, but we don't need high RPM. We need low RPM. So what we'll really tell is when I put it in the car. That's what's really going to tell. So anyways, so yeah, see, you get a better look at this. That's just that, like I said, that plug. Just got it taped together. This is a real relief to me. You know, that was a lot of work. So hopefully it works in the car. Okay, I thought I could get away with something here. I thought I could get away without showing you this. After all that work to rewind the what is this thing called? The armature. You know, I've got a couple of thoughts going around in my head here, and I think I probably didn't need to rewind the stator or the armature, but it did look bad. Like a lot of the coating was coming off the wires. It was all black. So it looked like it got pretty hot. So that's what led me to believe that that's what I needed to do. But in the end, the thing that was really keeping this motor from running was this right here. See that? That's the brush that connects to ground, and it goes right on here. So I guess at one time there was a little lug cast into this housing, and they just put this on there and then crimped it over. So after I initially put this all together and tried to test it on the bench, I had the wires hooked up and I hit the ground to the casing, and it just spun for like, you know, just went zzz, and then it kind of sparked a bit, and I think it turned one more time, and then it wouldn't turn. So I thought, what's going on here? So I opened this thing up, and then that's when I discovered that this was, it would just wiggle a little bit. So I just took a punch and I punched down on that, and that tightened the connection up long enough so that I could run it, and I thought, okay, I got it fixed. Anyways, put it in the car, and I don't know what's going on with the car, but and I think I might have it kind of figured out, but it's still, I could make the motor run in the car by, I ended up taking the cover off the relay that runs the motor and just depressing the contacts manually, and I could get the motor to run. And it was actually, so it was actually coming out of park. I think it was going into reverse, I'm not sure. And then I wasn't able to start the car. So the motor's working. The motor's working in the car, and then I was messing around with it, and then it stopped working. So then I came back, took it out again, came back, and this was loose again. So I tried to restake it, and there's nothing left of this thing. It just punched down below the level of this, basically. And it came off. So now I've got to come up with a solution to this problem. And I think what I'm going to do is I'm going to put this back in here, of course, where it needs to go. I'm going to solder a wire onto this, right onto this little eye here. I'm going to drill a hole here, through here, snake the wire out the hole, and then I'm going to put it you know, maybe even a longer wire. Well, it'll be longer. I'm either gonna bring it around the back of the motor housing and put it on, I think I'm just gonna put it on the screw that goes to hold the thing together. So that way it'll ground through the screws that go through this. So anyways, that's what I'm gonna do. And then from there I gotta figure out how to make it work in the car properly. There's something else going on there. I'm not sure what it is yet, but I couldn't get it figured out before this thing failed on me again. So anyways, I thought I could get away with something here, but I didn't. So anyways, let's just keep going here. I'm learning stuff. All right, so I've made the modification. I've got the external ground now. Just got a whole bunch of wire here that I'll trim off eventually, but I had another thought too, that maybe I made a mistake rewinding that armature and the motor's running backwards now from what it should be. So so now that I've got an external ground, it's not grounding through the case. I can hook power to this side and make it run the other way if that has to happen. So this is running really good. It's noisy because there we go. Just got to hold this. So that's a motor. That's running nicely. And it's turning in this direction. So that means it is unscrewing, I think. Yeah, it's unscrewing right now. Yeah, it's unscrewing. So let's see if I can make it run the other direction. See what happens. Yeah.
It's actually still running in the same direction. It hasn't changed directions by reversing the polarity.
So I don't know. I don't know what direction it's supposed to turn. I really don't. But it is unscrewing, which is, you know, I don't know if that matters or not. I really don't know what direction this is supposed to turn. So anyway, that's solved my grounding issue. So the next thing is to figure out, is it indeed running backwards? Is there some control problems? So anyway, we'll see. And I think it is running backwards. That's why it keeps pulling out of park when I hit the key. Okay, I'm learning about electric motors here. So because this motor has a field winding, which is the some motors have permanent magnets. This has field windings, so the electricity makes the magnet. And because it's a series motor, which means the power comes in here, goes through the field windings and magnetizes them, comes out here, this is the other side of the field winding, and then it connects to this brush right here, goes through the armature and comes out to ground here. So if I reverse the polarity on this thing the way it is now, the way I have this external. So I thought I could reverse the direction of the motor by just reversing hooking the positive to this lead and the negative to this lead, and that would turn the motor backwards, but it doesn't because I'm reversing the polarity on everything. So I just need to reverse the polarity on one thing. So I can't easily reverse the polarity on the armature without doing a complete rebuild on this thing. So the only way I'm going to do that is now I'm going to hook this wire here, this side, to where this wire was supposed to go. And I'm going to hook this wire onto the back of the brush holder right to here, where this wire was originally supposed to go. So that's going to reverse the field on the reverse the polarity on the field, and I've already tested this. It does turn the opposite direction, but I don't really know how they're reversing this motor on the car the way it was wired, because it just doesn't make any sense to me. There's no way out here that I could find by hooking, because there's this second wire here, right, or third wire, or whatever. So these are the only two connections that are made on the motor. This one and this one. And this has continuity with this. And then there's some thermal switches, a couple of thermal switches in here. It's bridged across. So it comes in here. There's this thermal sort of a switch thing. There's a kind of a bus bar that goes along here. It ties into this rivet. Then it comes along here, another thermal thing here, and then it goes here. Then from here it goes into the brushes, and it connects to this brush right here. So I don't know how they reverse the rotation of this motor. I just don't. I don't understand it at all. Sometimes you don't need to know how things work. You just have to accept that they work. So I'm just a little worried now that I'm reversing the field. Whatever witchcraft they're using to reverse this motor isn't going to work with the setup I'm going with. But I keep telling myself the electronics in this car don't know which side of this is hooked on the field. It doesn't know that. So it's going to, I'm hoping that it's just going to work the way it normally would. So anyways, I'm going to put it all together, put it on the car now and see what happens. So I just want to try and explain this mess I got myself into. So this is the armature. This is how you draw an armature, I guess, on a schematic. So what I did, I'm going to start here. I'm going to start somewhere in the middle. So the original motor winding was like this. It went over like this. Or, well, yeah. So came down like this, around this pole here, and then I'm not going to go around this 15 times, but this is the circuit. And then it crossed over to here, underneath this pole, or this commutator segment, and to this commutator segment. Hooked up there, and then you repeat the process, right? Come around here, around here, wrap it 15 times, and then you come across, up here again, and like this, across to the third one, and then hook it up here. Okay, so that was the original. I don't know how to spell that, so Original. Factory original. That's the factory original winding. Okay, this is what I did. I'm going to start here in the middle again. So I went down. I went down like this. Around here like this. And instead of crossing over to there, I hooked it to here. Right? And then you see what's going on here? Actually, I didn't. I probably should have just gone straight down here, but anyways. So then, from here, this will show you what's going on. And then around. So I just kept hooking back up on the left side of where I started. Right? Now it's starting to kind of overlap, which is okay. No, I don't have to go that far. So down here. Anyways, you get the idea, right? So, okay, if we're going to simplify this into terms of a lever action, okay, here's where I started. There's my fulcrum, right? Here's my fulcrum. So all the action is happening over here. This is where I'm pushing. So this is going to go, let's for argument's sake, let's just say it's going to go this way. Right? And this one is going to go this way too, but because it's on the other side. Okay, so if this is going this way, this has to go this way. And this has to go this way. So now we got opposite. We're doing the opposite. So that, you know, this is the easiest way I could explain this. That's what's going on in that motor. So, like I said, the way it's wired, if I just, you know, reverse the polarity on those, on my new ground and my hot wire, it just reversed everything. So it just kept turning in the same direction. It's hard to get your head around that. I had a hard time getting my head around it. You just have to change one. So now, if this was the field out here, right? Field windings. And I started out with plus there and minus here. If I change this, it's going to change the north-south pole, and it's going to act on this differently and cause it to turn a different direction. So there you go. Anyways, it's working. I'm happy. I hope you're happy. And we'll just keep fixing stuff. All right, here I am sitting in the car. Thing's in park now. So if I hit the key, it cranks. It's doing the typical Ford starter bug out thing. Starts. I put it in reverse. Goes in reverse. Put it in neutral. Goes into neutral. Shut the car off. It'll start in neutral apparently. Starts in neutral. Put it in drive. Goes into drive. And let's jam it back into park. Park. Shut it off. So there you go. Mission accomplished. Just got to button a few things up out under the hood. And this thing can go back to its owner. And I can get paid. Oh, there we go. That's that was frustrating. You know, I'm not a electrical engineer by any means. Man, that's the first time I've ever rewound a motor. I have had no need for it in the past. I've got, you know, all the little electric motors that I ever needed, starters, alternators, window motors. If they burned out, I just, you know, you just go buy a new one. But you just can't buy new parts for these cars anymore. There's a guy in the States that, in hindsight, I should have just ripped all this stuff out of here and sent it to him. He charges, I thought he charged $400 to rebuild your motor and everything, but turns out he charges $175. $225 maybe. It was $225, something like that. It was less than $400 anyways to do the job, and like it would have just. The only reason I didn't send it to him is just because I thought I could do this quicker, and maybe I did, but it was a lot of frustration. You know, it was just I was mad. I was mad at myself, and it really came down to that ground. I think it's a way better the way I've got it now. It's grounded. You know, you can't go wrong. It's not gonna. You know, the problem with aluminum is every time it heat cycles, if it gets hot a little bit, the things expand. Like they had that ring around it. It's a metal that expands at a different rate than aluminum. And if that thing, even like the aluminum expands out, and then when it cools off, it doesn't spring back. It just stays. So it just kept getting smaller and smaller, I guess, over the years. Every time it got hot, and it just lost connection. So now I've got it underneath the screw. There's no issue there. It's not gonna lose ground. So, anyways, yeah, I'm happy. This is a big relief to me. I've put a lot of work into this car. I've got a lot coming to me as far as the bill goes, and I just didn't feel right asking the guy for any money until it was in his driveway. So, anyways, thanks for watching. Go fix something. Go frustrate yourself. In the end, if you stick with it, you persevere, the rewards are there, right? I just feel really good about this right now. I've had this car in the shop way too long, so it's just good to finally get this resolved. So see you later. Thanks. So the giveaway is happening. So it's not my first giveaway pipe, but the first giveaway in this manner. So I'm going to show you 6 questions in a minute, and I was going to do 10, but I decided to go easy on you. It's only going to be 6, and the last question, the number 6 question, I'm just going to tell you is pretty much a giveaway because I tell you the answer to it in this video. So if you're watching this video, you will have heard me, unless you skipped through something, you will have heard me talk about this already. So I'll send this pipe anywhere in the world. It's a giveaway, it's a gift, so it shouldn't cost you anything, right? Other than a little bit of time. So, and the reason I'm doing this is because the question thing is because I want this pipe to go to somebody that watches my videos and has been watching my videos. That maybe, well, I guess that's not totally fair to the newcomers, but that's just the way it is. Sorry. My wife just said, oh, well. I know that a lot of the newcomers have been going back and watching my old videos. I know that because they're commenting on them. So thank you for that. And I want to thank everybody who has subscribed to my channel and got me to this point. So thank you. So anyways, the questions will be the video that you need to watch is going to be listed above the question. 6 questions. The email address is on the bottom. And so good luck. I look forward to communicating with whoever wins this thing. So the first person that sends all 6 answers, correct answers, gets the pipe. Just a little bit of advice for you. If you're watching these videos and you want to speed up I don't know if some people don't know this, you can actually speed up the video. There's ways you can do that. The way I do it is I just click on the top right corner of my screen on my phone. This little gear thing comes up, you tap on that, you go to playback speed, I think it is, and you can speed the videos up. So that'll cut your time a bit.